All right, good morning, everyone. Welcome back to Math 161. Just a couple reminders for previous due dates that were set. 2.1 and 2.2 are both going to be due on Thursday. Remember, you felt like you got a little extension on that 2.1 homework. And then we will finish, that says 2.4, but that should say 2.3. I just caught that. 2.3 will be on the 16th because we will be finishing that section today on equations of lines and graphing and stuff. So that's all I really needed to say real quickly. We're just going to go ahead and get back into it.
All right, so we're going to pick up where we left off in 2.3, which we hadn't gone too far in 2.3 so far. Linear functions and slope. We just said that any line can be formed by just 2 points. Yes, you can form a line with 3 or 4 or 5 or 6 or 7 points, or even more, but you only need 2 because by definition, lines are straight. So once you connect 2 points, the rest of them should just fall in place. Now, a third or a fourth or a fifth point are good ways to check to make sure that your line is accurate, that you didn't make a boo-boo somewhere. But if you're doing this by hand, it can actually, if you have, low artistic skills or are dealing with a drawing tablet where you can't actually see where you're writing, it can actually complicate things. So I'm a big fan of only using 2 points for my lines, especially in an advanced class. And then we said that we have the formula for slope, which is rise over run, rise being the change in height, run being the change in horizontal position. So if you're going through the points x1, y1, and x2, y2, remember points always go x, y. The ones need to be grouped, the twos need to be grouped. Your slope is just y2 minus y1 over x2 minus x1. And we are going to get another formula later in this section, or it might be in 2.4. I think it's in 2.4. And it's going to be very similar to this. And it's just going to be for functions instead of something in y equals form. And the notation will be different because it's going to be for functions. But we'll get there when we get there. And then we talked about how slopes can be positive, negative, 0, or undefined, and their basic visual appearances. And we just did some simple calculations of slope, and that was where we left off. So we're going to pick back up with what is known as the point slope form of a line. So we're going to learn, well, again, this is retreading old material, hopefully for you, unless you skipped a math class you shouldn't have skipped, that when we know a point that a line goes through, some x1, y1, so just 1 point, and the slope of the line, we can write the equation in this format known as point slope form. And the reason we call it point slope form is because you have a point and you have its slope. So the name tells you exactly what you have. Point slope form is called point slope form because in order to put something in point slope form, you need a point and its slope. So what is that form? Y minus y1 equals m times x minus x1. You have got to memorize this. It's never going away. I know I'm a broken record. Even with my broken record phase, I've said that like a dozen times already, right? This is never going away. When you take calculus, you're going to be using this periodically. I'm not going to say all semester long, but you will definitely use this periodically, especially more in the beginning. So there's nothing like having a calculus student who can do all these big, crazy, fancy formulas, and then you ask them what's the equation of a line, and they go, oh, how do you do that? This is old material. This is tying your shoes, and you never get to forget it. Okay. Now, here's what's cool about this format, this formula, excuse me. I'm just going to put a couple other little things here and then pretend like I divided it. Let me hit enter a few times. Instead of writing y and x here, I'm going to put little 2's here. Now, this is not part of the actual point slope form, but I'm just going to put them there. Now look at this, y2 minus y1, x2 minus x1, and there's an m. These are the same components that were in your slope formula, which was right here, y2 minus y1, x2 minus x1, and an m. In fact, what we see here is just an algebraic rearrangement of what we have here. If I were to divide both sides by that parentheses, what you end up with, and I'm going to erase this in just a second, I'm just showing you something, is the slope formula, y2 minus y1 over x2 minus x1 equals m. That's another thing that I hope to instill in my students, is that so many things are connected. So you might say, oh, well, you made me memorize this formula and that formula and this formula and that formula, when very often a lot of them are tied together, kind of like that quadratic formula. It was tied together with the discriminant, and it's going to be tied together with another formula we're going to learn in later in this chapter. No, chapter 3, excuse me. So that's your slope formula. So these two are heavily tied together. A slope formula is the same as a point slope form of a line. It's just you take the 2's out, because when we put 2's, we're saying it's a point, but when you write the letter y and the letter x, you're allowing them to change. It can represent any point, not just a single point. So that's something that I think is really cool, and I know that my definition of cool is not the same as most people's, but what are you going to do? Y minus y1 equals m times x minus x1. This is called just plug and chug. It's the same type of thing as going m equals y2 minus y, m equals y2 minus y1 over x2 minus x1. You're just plugging numbers into the right places. But you got to be careful when you're plugging these numbers in. You got to make sure they go in the correct place. All right. So for example 2, and this is A, we are going to write the equation of a line, or find the equation of a line, going through the point 2 comma 3 with a slope of 5, and then after we do that, we're going to graph it. Now there are many different ways to graph lines. We will be going over several of those methods today and maybe next class, if not just today. And in general, I'm not going to care how you graph your lines. My math lab might care if it says to use a specific method, but usually they don't care for this level. Okay. So let's start identifying information. What is what? 2, 3, 5. What are these numbers? Well, the point 2 comma 3, that's our x1 and our y1. That's the point. The slope is 5. It literally tells you the slope is 5. But what letter do we associate with slope? The slope is m. So that would be our m. Those are the 3 numbers that we're going to plug into this formula right here. All right, so I'll use blue for showing the substitutions. That's going to be y minus the y1 value was the 3 equals the m we said was this 5. Then we open a parentheses, and inside we're doing x minus x1. So x minus and x1 was the 2. I didn't reinvent the wheel here. I just plugged numbers into a formula. An A, a B, and a C, essentially. But instead of the letters A, B, and C, it's X1, Y1, and M. Now, they say to find the equation of the line. Technically, this is an acceptable answer. And what you're going to see in a lot of your homework questions, and quite possibly 1 or 2 test questions, is they're going to want you to write the answer in this format first, which is the point slope format. I'm just going to write PS format. PS format. But then what they'll also ask you to do is to put it in slope-intercept form, which I will go over it very shortly, but the gist is solve it for y. So in general, we need to take this and solve it for y so that we get it in a universally acceptable format. And it's not a lot of work to do that. Y minus 3 equals, we're going to distribute the 5 to the x and the negative 2. So that's 5x minus 10. And then all we got to do is move the 3 over. This is algebra that everyone should have up their sleeve. Negative 10 plus 3 is negative 7. Shouldn't need a calculator for that. It's no crazy addition or subtraction, just some sine numbers. Don't let them scare you. And then this is in what we call slope-intercept form, and we'll see that below. I'm not going to talk about what the 5 and the negative 7 represent yet, but I'm just going to say that if you solve it for y, you're in slope-intercept form. So generally what you do is you start in this format, and then you solve it for y. So in your homework, in your test, this would be one of the answers, and this would be one of the answers, and you got to make sure you put them in the right spots. If you swap them, they're wrong. And you might say, well, how do I know which one goes where? Well, the one you started with, this goes first. The one you end with, this goes last. All right, so the next thing they said was to graph it. We want to graph this line. Sometimes you're only asked for the equations. Sometimes you're asked for the equation and to graph the line. So there are many different ways to graph the lines, but I'm going to go over this method right here. The first method would be just to take this equation, that was our answer, y equals 5x minus 7, and you can just plug in whatever x numbers you like, which will give you y numbers, then you have your points. For instance, and again, this is not how I'm actually going to graph this, but I could say, what happens when x equals 0? Well, y would be 5 times 0 minus 7, which ends up being negative 7, so the point is 0, negative 7. And then I could say, what happens when I plug in x equals 1? You get y equals 5 times 1 minus 7, which is 5 minus 7, which is negative 2, and that point would be 1, negative 2. And then you just plot those 2 points, connect them, and extend them. That is very, very, very basic line graphing that everyone should still have, again, up their sleeve. And you are perfectly fine using that. So this is one way to graph the line. However, it's not the most efficient. When you have something in this y equals format, what you can do is use the slope to find a second point. Now, the slope was 5 here, which was the number that was here, and it's the same number that's here. So that's going to be one of the things we talk about with slope-intercept form, that the number in front of x is slope, but let's pause on that idea. And let's just go with what I've got here. Plot the first point. So we're going to plot the point given, which was 2, 3. You could plot 0, negative 7. You could plot 1, negative 2, and then do the next thing. We now have 3 points, but again, I'm going to pretend like I didn't actually do any of this. We're pretending I didn't do that. Again, it was perfectly fine unless the homework problem says to use this explicit method, to use the slope to find another point. All right, so plot the first point, then use the slope as rise over run. Remember, rise tells you how far up or down you're going, run tells you how far right you're going. There is no left. So you'll go right based on the run. So if your slope, oops, there we go. If your slope is, let's say, what letters do I want to use? A and B are fine, A over B. The bottom number tells you how far right you're going to go. You go right based on the run, which is the B. Remember, it's rise over run. Notice it says right. There's no left in this sentence. You never, ever go left. Just like when we talking about, just like when we were talking about increasing, decreasing constant, we always consider ourselves moving right. We really don't think about ourselves moving left when we're doing functional analysis. So you go right based on the run. So the denominator tells you how far right to go. And then the numerator, the top, tells you how far up or down to go based on the sign, based on rise. I have a typo here. Based on the sign. It's like a little dot there. Yep, I was right, there was one. So the top number tells you how far up or down to go. If it's positive up, if it's negative down, it's, what's the word I'm looking for? It's easy. Positive up, negative down. There is no left. The bottom tells you how far right to go. All right, so let's make our graph. Again, in my math lab, you don't have to do this by hand, but you should know how to do this by hand. So we had that point 2, 3, and the slope was 5. So 1, 2, 1, 2, 3. So here's our first point at 2, 3. Where did I get this 2, 3? It was given to me. We go through the point 2, 3. And then the slope is 5. But you need to use the slope as a rise over run. 5 is just written as a fraction. I mean, 5 is not written as a fraction. So what you need to do is say it's 5 over 1. So this whole number, to see the rise and the run, you need to write as a fraction. So this is pretty common. You don't want to write slopes answers as 5/1. You would want to write the answer as 5, but using this to graph so that we can say, all right, the denominator tells us how far right to go. The numerator tells us, since this is a positive 5, that we're going to go up 5. That's annoying. There's a truck backing up in front of my house. All right. If this had been negative, we'd be going down. Now, we're not going to start at the origin and go right 1 and up 5. When you're using the slope, once again, you do not start at the origin, you start at the previous point. So you plot the point first, then use the slope to go right and up from there. So from here, we're going to go right 1. So right 1, hold on, red, right 1, which would take us from an x value of 2 to 3. And then we're going to go up 5. So from a height of 5, so excuse me, from a height of 3, we would go up to 4, 5, 6, 7, 8. So just a little more based on that. There we go. So I'm going to skip labeling. Well, no, I won't. I can fit it. And there's our second point. So if you zoom in, go, you can see I went right 1 and up 5. 4, 5, 6, 7, 8. So this point was not at 1, 5. It's actually at 3, 8. And then you just connect the dots and extend them. Now I can't extend this vertically very far, but that's okay. And there we go. There's our graph. If you had used the points we found randomly that I erased of 0, -7 and 1, was it -2, you would end up with pretty much the same looking picture. Now, it's not scaled perfectly, so this section's a little off in that regard, but again, it would give you the exact same picture. The point of graphing these lines is, all right, well, we knew 0, -7 is a solution. We know 1, -2 is a solution. We know 2, 3 is a solution. Now we know 3, 8 is a solution, but this picture says this point's a solution, this point's a solution, this point's a solution, and you could get your microscope and a ruler and measure out every single one of these. So now instead of having to do arithmetic and algebra to get each new answer, we can just say there's a solution here, there's a solution here, there's a solution here, and we can extend this infinitely. We are representing billions and trillions and quintillions of answers with that picture. All the fraction ones in between, all the rational and irrational solutions in between. So graphs are awesome. A picture is worth a quintillion words, as they don't actually say, but that's the truth. All right. B, same exact instructions. We're going to find the equation of a line, and then we're going to graph it. Those are our instructions. Find the equation and then graph it. But this time I'm going to give you something different. Instead of giving you a point and a slope, I'm going to give you 2 points. And at first you might go, well, Mr. Beckner, how do we put something in point slope form if you don't give me the slope? That's an excellent question. And the answer is, I didn't give you the slope, but implicitly I did give you the slope. Implicitly means it's hidden. If I give you 2 points, you could label them x1, y1, x2, and y2. Well, the formula we gave you last time that we reassessed today was the slope formula, and it just needed 2 points. So we can find the slope first. That's not what I said down here. Yes, I did. Find the slope first if given 2 points. All right, so m equals y2 minus y1, that's 5 minus 0, over, make sure you're putting the pieces of the puzzle in the right place, watch out for subtracting negatives, hint, wink, nudge, over x2 minus x1, that's going to be 4 minus -1. This is wrong. This is seen so many times, but it's wrong. 4 minus -1, this says 4 minus 1. So make sure you're watching your double negatives. It's really 4 minus negative 1, which is 5 over 4 plus 1, which is 5 over 5, which is 1. So your slope is just a nice simple 1. Again, we didn't reinvent the wheel with this problem. It's just I didn't tell you you had to find the slope. You've got to know you need to find the slope, but you should know you can find the slope because you're given 2 points. If I only give you 1 point, you can't do this problem. You have to get 2 sets of information. I have to either give you 2 points or a point and a slope, or a third scenario we'll see in the next section that I don't want to spoil yet. All right, so now what do? You have TMI. Not that kind of TMI, but it is too much information because you now have 2 points and a slope, whereas the point slope form only requires 1 point. So if I give you 2 points, what do? Well, it's actually quite simple. You ignore one of the points. You just say, I'm only going to use this one, or I'm only going to use this one. And the cool thing is, when you solve it for y, it won't matter which one you start with. The answers will look different at first, but they're both 100% accurate. And I'm going to do this problem twice to prove that. I'm going to do it once using the first point. I'm going to do it once using the second point. So let's use the first point. I'm going to call it P, I'm on eraser, P1. So that was the -1 comma 0. So that's going to be the x1 and y1 in the formula. So we go y minus, the y1 is this 0, then equals the m, which we determined to be 1, and then times x minus x1, where the x1 is this -1, which again is a negative, so you got to wrap it in parentheses because of that double negative situation. And then what is the typical thing to do? Solve it for y. This is in point slope form. This is going to be one of your answers for many homework questions and 1 or 2 test questions, but you'll still need to take this further and solve it for y. So solve for y. Well, y minus 0 is just y equals -1 minus -1 is a +1, so that's 1 times x plus 1. Distributing a 1 does nothing, so you get y equals x plus 1. It's actually not too bad. All right, well, what if you instead chose to use the second point? What if you instead chose to use what we called x2, y2? In the formula, it doesn't matter that the formula has 1s and you're using 2s. You can just rename these. Call this x1 and this y1, and call this one over here x2 and y2. The choice of 1s and 2s is arbitrary. It's up to you as long as they're paired together. All right, so if we're using point 2, which is the 4 comma 5, now we go y minus 5 in blue for the substitution equals the m, which was 1, times the x minus the x1, which was the 4. Again, we chose to use this point, so now we're saying x1 is the 4. That was weird. I want to clean this up. That's an ugly little 5. There we go. All right, well, solve for y. You get y minus 5 equals, no double negative to fix, just distribute the 1, which does literally nothing. Add 5 to both sides. And you get y equals -4 plus 5 is 1, x plus 1. These are the same. But this and this, the starting equation, was different. Now here's the cool thing. In my math lab, in the homework and the test, it would have accepted for that first answer either of these red asterisks, but by the time you get to the second one, it knows there's only one version. So that's the strength of the y equals format. That's one of the strengths, that the answer is consistent no matter what point you actually plug in. But the point slope form, there are literally billions and trillions and quintillions of accurate answers. If I knew that the point 5 comma 6 works, I can go y minus 6 equals 1 times x minus 5. If I know the point 1 million comma 1 million and 1 works, I can go y minus 1,000,001 equals 1 parentheses x minus 1,000,000. that would be an accurate answer in point slope form. So it doesn't matter which point you plug into the point slope form if you have options, because by the time you get to the y equals format, they should be the same. This is actually a really good practice concept to make sure that your arithmetic is, pardon the pun, on point. Okay. So this thing, when we've taken these last two examples and solved it for y, I said it has a specific name, and that specific name is the slope-intercept form. Slope-intercept form. So if you have a slope and a y-intercept, now remember, intercepts always have 0 as one of the points, as one of the values, either the x or the y, that is to say. So remember, an x-intercept is always something, comma 0, and a y-intercept is always 0, comma something. And when you graph them, let's say we had a line that looked like this. I'm not putting any numbers up here. I'm just going to do some dots. This point right here would be the x-intercept because it's where it crosses the x-axis. And this point right here would be the y-intercept because it's where it crosses the y-axis. There is a strength to y-intercepts in these linear equations because their points are always 0, comma something. If it's solved for y, if you plug 0 in for x, if you plug 0 in right here, the slope times 0 is 0, so all that just goes away, and you're left with b. So whenever you're in this format, when you plug 0 in, the answer is always going to be that whatever number is here, which is what we call the y-intercept value. So x-intercepts always have a y-coordinate of 0 because the height has to be 0. Y-intercepts always have an x value that's 0 because the left or right positioning has to be 0. This is something that people get backwards a lot initially. They think an x-intercept should be 0, comma something, and a y-intercept should be something, comma 0. The 0 is opposite the name, though. That's the takeaway here. The 0 is opposite the name. In other words, x-intercept has a y value of 0, y-intercept has an x value of 0. You have got to know this all semester long. It's never going away. This issue is going to be in every single problem for several sections of both Chapter 3 and then maybe some problems in Chapter 4. And it could be in some problems in Chapter 2 as well. But Chapter 3, x and y-intercepts, we're going to be plotting very, very, very frequently. You've got to get used to that. If you're getting them backwards right now, say it a million times, write it a million times, apply it a million times, whatever it is you have to do. But practice is key. Growth mindset, very important. You might not be able to do it right now. You practice it a lot. You can definitely do it later. You can do anything as long as you practice. Our brains are just like muscles. You've got to use them to expand them. So y-intercept form, slope-intercept form is y equals mx plus b. So again, the y-intercept, we don't just say the y-intercept is b, and a lot of people will, and no one really complains when they do, but a y-intercept is specifically a point, and points have two values, an x and a y, and a y-intercept always has an x value that's 0. So I can actually go back to these previous problems, and I can say what that b value is. So for this problem, we can see y equals mx. It's a minus, but that just means change the sign for the b. So that says the m is still 5, which agreed with what we were given, so that's awesome. And because this is a minus 7, that says the b is negative 7. And we could say thusly that the y-intercept is 0, comma negative 7. Or for this one, when we were in y equals x plus 1, that says that the m is 1 because there's no number written in front of the x, so it's a 1. That's consistent with what we found, so that's good. And then this is a plus 1 here, so the b is positive 1. Thus, the y-intercept is 0, comma, positive 1. So in this format, you might actually pick up another point. Sometimes the point given to you is already a y-intercept. That wasn't the case for either A or B. And if that's the case, then when you put it in y-intercept form, you get another point, maybe a second point, or maybe even a third point. All right, so we didn't graph this last one. I just wanted to go ahead and talk about that slope-intercept form. So let's go back to the example and graph it, which was in the original instructions. Now, you got to tell me that's weird. My cursor's down here. When I hit enter, that's moving up. Whatever, man. All right, so we had the points, -1, 0, and 4, 5. Okay, so we'll space it like this. I'm just going to go like from -3 to +5, and the x's and the y values are between 0 and 5, so I just got to go up. 1, 2, 3, 4, 5. So what I could do is I could plot the y-intercept that I just noticed, 0, 1, and then I could use the slope being 1 to go right 1 and up 1 to find another point. But honestly, that's more work than I would personally do. And the reason is they gave you 2 points in the problem before you did anything. So it is my opinion that the easiest way to graph B is to just plot the 2 points they gave you. We weren't given 2 points in A, which is why I graph using the slope instead. And I'm going to say this again, I generally do not care how you graph your lines as long as you get an accurate picture. Some people will graph using 2 points. Some people will graph using one of the points and then the slope to find another one. As long as it's accurate, no care. All right, so that was -1, 0, which will be left 1, up or down nothing. So that's actually an x-intercept. And then the other point was 4, 5, so we go right 4 and up 5, which will put us here. We connect and extend as straight as we possibly can, which is a challenge for me on this tablet. I'm already a poor artist, and then I'm flying blind. There's our line. Now again, due to making this by hand and on a crummy tablet, if I did this on the board, this would have actually hit this point right here. That would have been 0, 1, and the line would have gone through it. This is just poor artistic skill. But again, someone who did this the other way, they would have said, all right, well, let me plot that 0, 1 point, which is right here. There's your y-intercept. And then from that, because the slope was 1, which is 1 over 1, you go right 1 and up 1. So you go right 1, up 1, and that would put us at 1, 2. And again, besides just minor artistic inability, ineptitude, and blind tablets, that's pretty much the same line. Now, someone else might end up drawing it much steeper, or someone else might end up drawing it much flatter. That just depends on how you scale your numbers. If you're drawing this completely by hand, I can make this 10 billion different appearances and all be accurate as long as they go through the 2 points that we discovered. Like maybe instead of having this be 5, maybe I chose this to be 500,000 for some ridiculous reason. That would make my line almost look vertical. All right, so remember your point slope form, which is generally where you're going to start your lines, is y minus y1 equals m times x minus x1. You all have that memorized already, right? Right. Then your slope-intercept form, what I call SI form, is y equals mx plus b. Usually you're starting here and you're ending here. That's generally the idea. Yes, there are ways that you can just jam your point into slope-intercept form and then figure out what the b is or the m is. And if you understand that method and you can practice it and get them right every time, you're more than welcome to do that. I'm not going to teach it though, because I don't have the time and I just want to have some consistency. But again, I'm generally accepting of alternate methods. It is very rare that you can use another method that actually works and I'll go, no, don't do that. I'm going to take away points. That's not fair. My motto is get the job done in whatever way actually works. I'm a realist. All right. So example 3. Write the equation of a line going through the point 3 comma negative 1 with a slope of 2 in slope-intercept form. Now, this is the exact same thing we did in example 2 earlier. There's nothing new, and then we want to graph it. So what's our point? 3 comma negative 1, that's our x1 and our y1. What's our slope? They told us the slope was 2, so this is our m. We don't need to find the slope, and b, let's just put that further away for now. Thank you. So we got our point and our slope, so we can put it in point slope form. We go y minus y1. So y minus the y1 is negative 1, so we're going to need to wrap it into parentheses, equals. Then the m, which was 2, then parentheses, x minus the x1, which was 3. There is our equation in point slope form. This is an equation of a line. This is an answer if all someone says is write the equation of a line. However, it's just generally known that we want to solve it for y, which is explicitly slope-intercept form. So let's clean this up and solve for y. We'll get y plus 1 equals, go ahead and distribute the 2. You get 2x minus 6. Let's subtract 1 on both sides. I almost said add 1. And you'll get y equals 2x minus 7. That is our answer in slope-intercept form. And then we were asked to graph. Now, they gave us this point right here, 3 comma negative 1. Now that we're in slope-intercept form, you can confirm that the slope is still 2. Well, that's good. You can say, all right, that's a negative 7, so your b is negative 7. Thus, your y-intercept is 0 comma negative 7. So you could actually use this point and this point to make your graph. You could just plot 3 comma negative 1. You can plot 0 comma negative 7. And boom, connect, you're done. However, I want to practice using the slope to graph more because I think that throws people more for a loop. So you can go on your own and just plot those 2 points and see what you get. But I would also like you to do what I'm about to do. So we said our slope was 2, which we need to write as 2 over 1 so we can see the rise and the run. The bottom is 1, that's how far we go right, never left. The top is 2, so that's how far we're going to go up since it's positive, down if it had been negative. So I'm going to plot the 3 comma negative 1, go right 1 and then up 2, and boom, I'll have a second point. So 3 comma negative 1. And let's do this. I can make that a little better. We can rebuild it. We have the technology. Dang. And you're probably thinking, Mr. Beckner, why don't you just use a ruler? Because I can't see how to place the ruler. All right, so 3 comma negative 1, that's right 3, and down 1. Notice I just build these numbers as I need. And that point would be right here. Then from that point, I'll go right 1 from 3 to 4. And you don't have to show these little horizontal bits. I'm just trying to demonstrate the going right 1 aspect. And then we go up 2. So from a height of negative 1, we'll go up to a height of positive 1. How did I know that? I counted. I added. So up 1, 2. And there's our second point. Connect and extend. And boom. So we had the y-intercept of 0, negative 7. If I was an awesome grapher, then that says this point right here would have a height of negative 7. Now, if I did this with a ruler and grids and all that stuff, it would be negative 7. I can promise you that. I could have plotted the 0 comma negative 7 and from that gone right 1 up 2. And in fact, if you go right 1 up 2, right 1 up 2, right 1 up 2, you'll end up here, then right 1 up 2, you'll end up here. You can keep doing this, right 1 up 2, another point, right 1 up 2, another point. You can keep doing that if you wanted to, but there's no reason to do it more than once. There's our line. It's a little bendy, but just ignore the bendiness. It's flexible. Got enough space? Yeah, we got enough space. B, -1 comma -5. That's our point, and our slope is -3. We're going to graph it as well as write the equation in slope-intercept form. Same instructions as last time. So we have our x1 and our y1. I do encourage you to label things. I already labeled the m quite literally. I could have said the slope is -3, and then I'd go back and write m, but I wrote m already. So put it in point slope form. Y minus y1, which is -5, so parentheses it, then equals the m, which is a -3, open a parentheses, then x minus the x1, also negative, so another parentheses. Make sure you have the right number of opening and closing parentheses. You definitely don't want to miss one of those. Be a silly minor mistake. And then we just clean this up. We got to solve it for y. So that's going to give us y plus 5 on the left. That'll be -3 parentheses x plus 1. Don't distribute that in the same instance unless you just know you'll get it right. But even I would make a mistake occasionally trying to do too much at once. So take your time. Now distribute y plus 5 equals -3x. I'm going to make a mistake, plus 3. This is a common mistake. That's my mistake. I didn't distribute the negative correctly. Make sure that's a -3. Then all we got to do is move the 5 by subtracting on both sides. Sometimes it's adding, sometimes it's subtracting, just depends on the format. So y equals -3x. -3 minus 5 is -8. And that is our answer in slope-intercept form. The top one was point-slope form. How do I know that something, why is the name slope-intercept form? Because you have the slope and you have one of the values of the intercept, the y-intercept specifically. There's no x-intercept form. There's no reason to have something in an x-intercept form. Not for us, at least. So again, you can actually go and say if you want to, the m is still -3, that's confirmed, but the b is -8, so the y-intercept is 0, -8. That would give you a second point that you could just plot and connect to the first point, and there you go. You don't have to use the slope. However, for more practice using the slope, I'm going to do it that way. So I would suggest that you on your own try and graph it using those 2 points. But I'm going to show it with the slope. So if our slope is -3, we should probably write that as -3/1 so that we can see we go down 3 and right 1. Or right 1 and down 3. The order you go right and then up or down doesn't matter. As long as you don't go right 3 and down 1, that would be wrong. So I'm going to plot the -1, -5. I'm going to need more of a bottom-heavy graph this time. So let's do it like this. -1 is left 1, down 1, 2, 3, 4, 5. So -1, -5 is right here. And from that point, we're going to go right 1. Here's me going right 1 to x equals 0. And then we're going to go down 3. So that'll take us to -6, -7, -8. So here's this going down 3. Boom, there's our second point. Right 1, down 3. Or you can go down 3, right 1. You still end up there. Connect and extend. And my math lab does that part for you. It's a little too easy in my opinion. And there we go, there's our line. And this one I really like. I love this example that I made because check out this point right here. That point is 0, -8. It actually confirms the y-intercept. We happen to pick it up just by using the slope from plotting the first point and then just going right 1 down 3, we coincidentally ended up picking up the y-intercept. Doesn't always happen, but it's cool when it does. At least it makes us feel, confident, I guess. So like I said, you could plot the -1, 5, you could discover the y-intercept and plot it, boom, you'll make the same line. You can plot the first point, and then from that you can go down and right 3. So down 3, right 1, excuse me, boom, second point. If you don't like using the -1, -5, maybe you plot this as your first point, and from that point you go down 3 and right 1. You go down 3 and right 1, and you'd end up over at 1, -11, and you'd connect them, and you get the same exact line. How are we on time? About 25 minutes. All right. So far I've showed you how to graph using just 2 points, whether they're a y-intercept, 2 given points, whatever. I've showed you that you can plug in whatever x values you want. Maybe I don't want to use any of this given information. I know my equations, right? Maybe I just want to plug in x equals 5 and x equals 9 for some reason, and then you'll end up getting the y equal values, and then you just plot those 2 points and boom, you've got your line. There's nothing that says explicitly in general that you have to use any of the methods that I've done so far. You can create your own points. Just how do I know to pick 5 and 9? I don't know to pick 5 and 9. I just said, hey, I'm going to pick 5 and 9. Maybe Bob picks 2 and -4 for the x values. Maybe Jane picks 1,000,000 and then 14 for her x values. But you can't pick the y values. You have to plug the x values in to find the y values. There's another great way of graphing some lines whenever the variables are all on the same side to begin with. And it still works fine with any of the examples we've done so far, but it's a personal favorite of mine for something that looks like this 4x minus 5y equals 40. So I'm going to teach you how to graph using intercepts now. Mr. Beckner, you just taught us how to graph using a y-intercept. Using a y-intercept, but we haven't used an x-intercept. We happen to pick up one time, but I'm saying just know that you're going to graph using intercepts. Graphing using intercepts is nice because to plot a point, you don't go right and up or right and down or left and up and left and down. You just go left, or you just go right, or you just go up, or you just go down. Those points will always be sitting on the axis, which I think helps some people make more accurate graphs. Now again, any of the previous examples, you could use this method to graph them. However, sometimes you end up getting fractions involved, and it's not the end of the world. It just means you might have a fraction. It's just not optimal. So to graph using intercepts, one time let the x be 0, which would be the y-intercept. Then for your second point, let the y be 0, which would be your x-intercept. There's your 2 points, plot them, connect them, boom, you're done. So this is best when the variables on the same side. The previous equations I gave you, none of them had the x's and the y's on the same side because you had to create the equation using point-slope form and then get to slope-intercept form. This example right here 4, I'm not asking you to create the equation, I'm giving it to you, and it just so happens that it has the variables on the same side. So here's what I like to do. I start with a table of values where one time I let the x be 0 and one time I let the y be 0. That's how we graph using intercepts. Now again, please pay attention in your homework. If the instructions say to graph using a specific method, yes, you have to graph using that method. When it's test time, if there's a problem where you graph, if it says to use a method and your line is accurate, but you didn't use their method, so they don't give you points for it, that's a case where you could shoot me an email and say, hey, Mr. Beckner, check out my work. I'll confirm your work looks good, that your answer is good, you just used a different method. And then I would give you either 4 to 5 points or all 5 points, just depending on whether I say, well, I really do want you to use the instructions for that. But even still, 4 to 5 points is better than 0, which would not be fair in my opinion. All All right, so when we plug in x equals 0, you got to do these one at a time. You can't just make them both 0. That would be too much of an assumption. We get 4 times, so plugging in with blue, 0, minus 5y equals 40. Well, 4 times 0 is 0. 0 minus 5y is just minus 5y. Anything times 0, that just goes away. So we're left with the minus 5y. That is one of the strengths of the intercept method. When you plug in zeros, something's going to immediately go away, and you're going to get a pretty simple looking equation. Divide both sides by -5, and we get y equals -8. And on the right side, I'm going to show my completed table of values. So this is what we start with. When we plugged in x equals 0, we get y equals -8. Now let's start over, start from scratch. We're going to plug in y equals 0. So that's 4x minus 5 times 0 equals 40. 5 times 0 is 0, minus 0 does nothing, all that just goes away. Again, the strength of plugging in a 0. So we get 4x equals 40, wrong color. Divide both sides by 4, and we get x equals 10. So the completed table of values is on the right side. 0, -8, that's our first point. 10, 0, that's our second point. I would highly suggest, I did not ask you to label which type of intercepts these are, but it's a great idea because you will need to know which is which. It's nice knowing that, oh, well, this is an intercept because I see a 0. This is an intercept because I see a 0. But you will need to know these names explicitly sooner than later. So the x is 0, that makes that the y-intercept. When the y is 0, that makes it the x-intercept. So we can graph our line now. And here's my favorite aspect of doing this by hand. I'm not going to go on my x-axis. I'm not going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'm not going to do that. I'm just going to put 1 dash and put 10 because that's literally the only x value I need. Same for the y's. I'm not going to go 1, 2, 3, 4, 5, 6, 7, 8. I don't know why I changed color. I'm just going to go down here and write -8. Make sure you don't do it up here. That would not be right because that height is -8, not +8. Make sure you're going left or down appropriately. And then where are the points? Well, they're actually going to be exactly there. 0, -8 is left or right, nothing, down 8. Then 10, 0 is right 10 and up or down nothing. It's very easy to get the zeros backwards and think I was supposed to go left 8 and up 10. So please be careful. The y-intercept, well, that's sitting on the y-axis, so that's a good sign. The x-intercept is sitting on the x-axis, so that's a good sign. Connect and extend. Oh, wow, that got bad. Let's just thicken that up to make it look a little straighter there. There we go. That just doesn't look good. That's better. I can live with that. Have I said I missed the whiteboard? I missed the whiteboard. All right, that is almost the end of the section. I will take that into account. I'll check that in. I'll check into that and see if I can use it. Thank you. Always appreciate advice. All right. Horizontal and vertical lines. We mentioned much earlier last class that slopes can be positive, and when they're positive, they look like this. Slopes can be negative, and they look like this. It's all about going right and up, or right and down. If the slope is 0, it's completely horizontal. If the slope is undefined, it's completely vertical. When you have equations of lines that are these last two cases, they actually don't have the x's and the y's in them. You only get one of them, because for this first one, the y value is constant, so it never changes, so you can't allow it to change. It can't be based on the x value. For this fourth one, the x value is constant, it never changes, so the y value can't have any dependency. So it turns out, and you'll see the notes below, that whenever you have a horizontal line, it is always of the form just y equals a number, and that number tells you how far up or down it is. So let's say this height was 7, it would be y equals 7. If this height was 20, it would be y equals 20. And then vertical lines, because it's located at a specific x value, it's x equals a number. There is no x in this third case. There is no y in this fourth case, because the y value has nothing to do with the x value. They're completely independent. It's a special case. I just don't want that displayed yet for my permanent notes. So horizontal, I'll just redraw them up here. Horizontal lines look like this. That would be y equals a number. Vertical lines look like this, and that would be x equals a number. Yes, there are more methodical things you can do to prove this and verify it. We don't have the time to retread through that. That's something that you should be discussing in a previous algebra class. You can still take these and plug in values, but you'll only be able to plug in, like if you have y equals, you can only try and plug in x values, but there'll be nowhere to plug it in. If it says x equals, there will be nowhere to plug in a y value, so the x is just what it says. You can't plug y values into the first because it might be a lie. You can't plug x values into the second because it might be a lie. So I didn't have them typed. What number are we up to? Example 5. Last example for the section. Graph the line. A, we're going to do x equals 13. And I'll go ahead and show you what b is going to be. B is going to be y equals -6. Right, so x equals 13. There's no y in this, which means special case. X equals a number says that the x value is always 13. So let me just show you a way you can rationalize this. All right, no matter how high up you are, the x value is always 13. So if 13 is all the way over here, there's a point here because the x value is 13. Doesn't matter what the y is. There's a point here because the x value is 13. It doesn't matter what the y is. There's a point here, there's a point here, there's a point here. All the points have to be going right 13 because this says x has to be 13. But the y value doesn't say anything about it. There's no y anywhere to plug in. So there are all the points. And then you could just make 2 and connect them, which is what you would do in my math lab. But me, by hand, I just go ahead and draw the vertical line, and that's it. I can also, for bonus points, not actual bonus points, but since it's a vertical line, I know that that slope is undefined. I didn't ask for that, but it's nice to say. For y equals -6, that's a little slanted. Just like the Earth's axis, it was a little tilted. All right, so y equals -6, that says no matter how far left or right you go, the y value is always -6. So we need to have a height of -6 up here. So there would be a point here, there'd be a point here, there'd be a point here. No matter how far left or right we go, we're always going down 6, and then there's our line. But again, me personally doing this by hand, I just go ahead and draw the horizontal line. It's a shortcut. In my math lab, you can just click any 2 points with a height of -6. You can click here and here. Or you can click here and here. Or you can click really ridiculously close to each other. It doesn't matter. Or I can go far left and far right. Don't overthink it. It's simple. And then again, for karma points, what's the slope? Horizontal lines have a slope of 0. The way I used to always say this, and I don't think I've said it in a while, but the way I like to remember that the slope is undefined for vertical lines is slope is a measure of steepness. The steeper the line, the harder it would be to climb up. So 0 is the easiest thing just to walk across. It's a flat surface. 1 would be a little steeper. 2 would be a little steeper. 3 would be a little steeper. So the larger the number, the tougher it would be to walk across. Unless you're Spider-Man, no one is walking across that because it's just going up a wall, or unless you've got some suction cups or something. So that's why it's the weirdest answer of all, undefined. All right, so that ends our.
Give me about 20 seconds, everyone. Sorry about that.
More on slope. So 2.3, the main topic was slope, but also with lines. In 2.4, we're going to talk about more things with slope, not just dealing with one line, but dealing with two lines simultaneously. So that's a common theme in algebra and calculus moving forward, that you'll have simultaneous equations or a system of equations. And sometimes they can have special relationships to each other, like they're parallel, which means in a Euclidean geometry system. Don't worry about what it means to be non-Euclidean. It will make your brains explode, I think. But the basic idea is that in non-Euclidean geometry is lines, all lines intersect, even parallel lines. Very weird. It'll hurt your brain. It hurts mine a little bit just to think about. Lines meet at a right angle. So parallel lines look like this without the highlighting. Please stop highlighting. Thank you. So that would be parallel. Perpendicular lines meet at right angles. I can do a little better than that. There we go. So that would be perpendicular. That is a 90-degree angle. Parallel lines never intersect. Perpendicular lines meet at a right angle. Those are two very important concepts. If you're going to be going on to calculus, you'll talk about what it means to be orthogonal, and you take this idea of perpendicular lines and you extend it into multiple dimensions, even past 3 dimensions, and really start getting into some crazy cool stuff. All right, so if you have the slope of one line and you know they're parallel, then that means you automatically know the slope of the other line, because if this line goes right 1 and up 2, and then right 1 up 2, right 1 up 2, the parallel line would have to do the same thing, right 1 up 2, right 1 up 2, right 1 up 2, so their slopes would have to match. The slopes are equal. That's saying the m's are equal, yay, exclamation mark. So that one's pretty obvious. Doing the proof of perpendicular lines, the proof of this equation right here, is time consuming, so just take it with a grain of salt. Provable, you can just Google that if you want, but I don't want to take the 30 minutes to prove it. I think we have more important fish to fry. So parallel lines have equal slope. So if you know the slope of the first line, that just says make the slope of the second line the same exact thing. So if I tell you the first line has a slope of 5, that means the second line also has a slope of 5. Whereas perpendicular lines are a little more complicated. They have negative reciprocal slopes. Reciprocal, remember that means to flip the fraction. So this 1 over m1, that's what that demonstrates, flipping the fraction. So if it was originally a slope of 5, flipping would be 1/5. If it was originally a slope of 2 over 3, flipping it would give 3 over 2. But it's not just flipping, it also means to change the sign. So perpendicular lines always have opposite slopes. So that's why this negative is in that formula. So you flip it and change the sign. You flip it and change the sign. You flip it and do what? change the sign. If you only do one of those two things, it's going to be wrong. I'll bump it down that far. There we go. This is I think we have just enough time to do example 1, and then we'll pick back up next time with example 2. Write the equation of a line going through the point 1, 4. How do I know that's a point? Because it's a pair of numbers inside of a comma. And we're talking about an equation of a line. So it's not interval notation. And parallel to the equation, I didn't even give you the slope. I gave you an equation, y equals 5x plus 800. And I ask you to write our new equation, our second line, in slope-intercept form. So you've got to make sure you're solving for y. So what do you do here? I did not give you the slope. I gave you the point, though. I gave you the x1 and the y1. The 1 is the x1. The 4 is the y1. But where's the m? What's slope, Mr. Beckner? You didn't tell me a slope of the line so that I can make a parallel slope or a perpendicular slope, whichever it is. Well, I gave you an equation. So this is just some random equation that we only care a little bit about. The little bit we care about is its slope. So we're going to say, what is the slope of the given equation? I can spell, just trying to type too fast. Well, it's solve for y, which says the number in front of the x should be the slope. That was hard. If it's not solve for y, guess what you do? I hope you guessed. That's right, you solve it for y. So the slope of the line we need is 5. Let's call that M1. So the slope of the first line. So this is line 1. Now what we need to do is make line 2. Line 2, well, what's its slope? Well, they're parallel lines, which means they are equal slope. You don't have to do anything to it. The slope of the first one was 5, so the slope of the second one is 5. So now we have the slope the line goes through. We have a point that our line goes through. We're going to use that information. This line, this y equals 5x plus 800, so many people want to just try and change something in here, like this 800 to a 4 and the x to a 1 maybe, or maybe even something else. No, this is now in the dumpster. It's trash. Set it on fire. Whatever you need to think about. Now, don't permanently scratch it out in your notes because you'll need to come back to it, but just maybe make a little memo down here that the y equals 5x plus 800 is now trash. Don't go back to it. So we go y minus y1. We're using this point and this slope. So y minus 4 is equal to the m, which is 5, then times x minus the x1, which is up here, and that's our 1. Now you might be thinking, Mr. Beckner, that says M2 and these are X1 and Y1. Disregard that. I could have labeled these X3 and Y3. I could have labeled them X a million and Y a million. The number choices are arbitrary. This is our equation in point slope form, but we need to solve it for Y. So distribute the 5. We get Y minus 4 is equal to 5X minus 5. Add the 4 to both sides and you'll be done. And that gives us Y equals 5X minus 1, and that is our equation in slope-intercept form. I did not ask for the graph, so we are done at that point. And there we are.
All right, so obviously we did not even come close to finishing 2.4. We will talk about that more on Thursday's class. Just a quick reminder of due dates. And if I didn't say it earlier, the reason 2.3 is pushed so far back, 2 weeks instead of 1 week, it's because spring break. And I'm not going to have things due over spring break. You should still be working on stuff, maybe take a chance to read ahead, look at some homeworks that are ahead, or just really brush up. But besides that, not going to actually have anything due. All right, so we will see you on Thursday to finish 2.4. Besides that, have a good day.